Hello everyone, welcome to this talk. Today we'll be taking a look at how coroutine works and how they compare to RxJava if we regarding to the networking architecture of our Android app. But first, let's take a look at what networking on Android means. And when we usually talk about networking, we also have to understand how background jobs work on Android and what the solutions that the framework provides us are. So usually when you want to do something in the background on Android, you rely on something like this. So runnable handle, async tasks, intent service, and the newest work manager. And we also have multiple options that we can adopt to run background tasks for our Android application. But when we look especially at the latest trends in the Android community, the majority of the Android developers have been using ReactiveX in particular, and in particular RxJava. Let's look at what ReactiveX and RxJava is. Is an API for asynchronous programming with observable streams. The thing is that when you consider what RxJava does and the ReactiveX, and you look at this definition, we are talking here about streams. But most of the times, when we are doing networking stuff, we are not working with streams, because usually it's just call, response, mapping, and display the result to the users. Streams are useful for all sorts of things on Android other than networking, and that's also the reason why the community worked really hard to create multiple libraries to, for example, handle preferences, cache, sensors, lifecycle events as streams. And RxJava is great for this. If you're adopting a reactive architecture for your Android app, it's great. You can literally treat everything as a stream. But when you look at the what we can consider primitives of RxJava, we usually have flowable, observable, single, completable, and maybe. And then when you use RxJava with networking, you usually end up using just these two, single and completable. Single because we are just making a single request and receiving a single response, and completable when we actually don't care about the response payload. We just care whether it's successful or not. And when you have to deal with all these kind of primitives, you usually end up with something like this. When you're doing some transformation, you're zipping, you're mixing multiple flows, and at the end you have to switch thread. You decide where to handle the result, where to handle the error. And of course, this can be really hard because the problem with this is that there is a really steep learning curve. So if you are hiring a new Android developer to your team and they don't have any previous experience with RxJava, most likely they will have a really hard time if you have really complex flows. And another problem is that this logic is really complex and error-prone, mainly because it's really hard to code review and debug. For example, if you have a complex flow like the previous one, it might look right when you're actually reviewing that one in a PR, for example, but you're assuming that the flow works as you expected. Because it's really hard to understand, for example, if you have a flat map, you're actually changing what the next operator is receiving. So you have to keep all this transformation in mind. And the purpose of this talk is actually presenting you with a simpler solution for networking specifically, which is coroutines. Let's have a quick overview of what coroutines are. Coroutines are a feature of the Kotlin language, and they are an instance of a suspendable computation. You can suspend the execution without blocking the current thread, and it's also conceptually similar to a thread in a sense that you have a block, you can start it, and it basically has the same life cycle of a JVM thread. Um, but also one advantage is that it's actually not bound to any thread, even though it has a lot of similarities with threads. That's because we can suspend the execution in one thread and, for example, resume into another. And we will understand what this actually means soon. Another major advantage of coroutines is that they're really super lightweight. They are simple state machines. They are objects, basically. So if you compare them to threads, which are really full-blown environments, really complex environments, there are multiple benchmarks that you can find online that will prove you that you can run literally thousands of coroutines without having a huge impact on your resource consumptions. So this was a quick overview of coroutines. Now let's see how coroutines integrates with Retrofit, which is the main networking library that we usually use for Android. For example, here we can see that on the left we have a classic Retrofit interface implemented using RxJava. So we have two get calls. We are using single, and the first one is returning a single of the list of users. The second one is returning a single of user. On the right, we have the coroutine implementation in Kotlin. And the main difference, as you can see, is that we are replacing single with deferred. So at this point, you might say, okay, yeah, but we are still wrapping our result in like something else, an object. So actually, it's not changing that much. But the cool thing is that Retrofit will soon actually support suspendable functions. In fact, in the Retrofit 2.5.1 snapshot, we can remove the deferred object as return type and just add the suspend keyword at the beginning of the function. And it will work just out of the box. Currently it's in alpha, so hopefully it will become stable soon. But in the meanwhile, you can still use deferred. But for the rest of this presentation, we will adopt this style of writing Retrofit interfaces. So okay, this is our Retrofit interface, and at some point we have to also use this. So let's have a look at how we would use this in RxJava. We would have something like this. So we have our Retrofit API. We are calling get users, for example. Then we are subscribing on, for example, schedulers.io, and this is where our network call will actually happen. Then we have observe on Android schedulers.main thread. This means that the actual result of our network call will happen on the Android main thread. So here we are, while we are calling this network endpoint, we are specifying where it needs to happen. So in the iOS thread pool in this case, and where the results need to be handled. Now let's have a look at how we can do the same thing using the coroutine implementation of our Retrofit interface. This is a comparison side by side, and on the right we have coroutines. And the main difference is that we don't have a chain of operations. We just call API get users, and then we do whatever we want. We have to wrap it into a try catch, because of course it can throw an exception. Yeah, so all we are doing is calling our suspend interface here in our code. But actually, this is wrong, because if you try to write something like this in Android Studio, you will get an error in the editor itself, a compile time, that will say the suspend function get user should only be called from a coroutine or another suspend function. So at this point, you can create another suspend function in your code and call this api.getUser. But at some point, you actually have to call it from your real code. And this is where CoreTeamBuilders come in. CoreTeamBuilders are basically an entry point to our suspendable code. It's what we use to actually call suspendable functions from our application code. And we have 3 built-in builders, which are also quite self-descriptive. We have, for example, the run blocking builder that blocks the execution of our code until the suspendable code finishes. Then we have the async, which allows us to run several background tasks in parallel without stopping the execution of our code. And then we can call await when we actually need to do something with the result. And then we have launch, which is the main builder. It's what we will use most of the times. So now let's take these coroutine builders, specifically the launch one, and let's apply it to our previous piece of code. This is what it looks like. This is the one that is actually not working. All we have to do is to wrap it inside launch. And at this point, it will not throw an error anymore. Now, everything inside launch is a coroutine, is running inside a coroutine, so it's running. It's not part of our main application code. But at the beginning, this might look right, but actually it's not. It's not, because if we go back at our RxJava implementation, you might remember that we were actually switching the thread where the network call was happening, and we were explicitly saying that this needed to happen in the schedulers.io thread pool. So how can we do the same using coroutines? The solution is something called coroutine dispatchers. Coroutine dispatcher is something that can confine a coroutine execution to a specific thread pool, or leave it just unconfined. So in this case, if we want to specify, if we want to instruct our coroutine to use a specific thread pool to make our network call, all we have to do is to add a parameter to our launch coroutine builder. And in this case is dispatchers.io. Dispatchers.io is a bit like schedulers in the Rx world, and we have 4 different dispatchers built in coroutines. We have dispatchers.default, which is the default thread pool, and it's the one that it's applied by default when we are actually not specifying any dispatcher. So for example, in the previous example, where we didn't specify any dispatcher, we were actually using the default one. Then we also have dispatchers.main, which instructs the coroutine to run into the main thread operating with UI objects. And this is actually pretty cool, because it also it's quite smart, because depending on the platform that on the framework that you are using, it will actually choose the correct thread. For example, on Android, it will use the main thread, the UI thread. If you are writing, for example, a JavaFX application, it will use the correct thread, the UI thread in that case. So this is what we usually want to use when we want to do some UI operations. Then we have dispatchers.unconfined, which doesn't have any threading policy, and probably it's not something that should be used for production code. Then we also have dispatchers.io, which is the one that we are using in this case, which is used to offload I/O tasks. So, and in this case, this is a thread pool in which threads are created on demand. So it's quite flexible. For example, as I was saying before, if we want that dispatchers.main uses the Android UI thread by default, we have to include also this dependency to our project that will actually instruct coroutines to use the correct thread as dispatchers.main. So, okay, this is our functioning kind of code. We are actually doing the network call in the I/O thread at this moment. But if we go back again to our RxJava implementation, we remember that we also had observe on. And this was the point where we were saying, okay, I want to run the result of our of this chain in the Android main thread. And guess what? We can do the same in coroutines using the with context block that allows us to switch the context of the execution. So for example, if we go back to our coroutine call, In this case, we want to call that show users in the UI thread, for example, because we are actually doing some UI rendering. And how we can make this work is by wrapping it inside with context and putting dispatchers.main as as a context of that CoreTeamBuilder. So now our API.getUsers will actually run in dispatchers.io, so in a thread, the thread for I/O operations, and show users will be called on the main Android UI thread. So let's just recap what this context means, what this for example, if you compare RxJava with coroutines, you might have noticed that the RxJava subscribe on corresponds to the initial context, which is what we put inside the argument of the launch CoreTeamBuilder. Then we have observe on, which is used to switch the thread for the result of our network call, and in that case, we need to use with context. Now, at this point, you might be wondering, what is this context word that is popping out everywhere? Well, actually, every CoreTeamBuilder has a context. Even if you don't specify it, it has had default context. And the context basically represents, contains some useful variables, some useful objects that can be used inside the coroutine itself. If you look at the context implementation of CoreTeamBuilders, it's basically a map of values. For example, you can assign a name to a coroutine, which can be useful for debug purposes. You can set the scheduler, the thread pool, so which is what we are doing with dispatchers in that case, and a lot of different things. Let's go back to our RxJava implementation. And probably, if you're doing something like this in a production app, you would also want to handle cancellation for this network call. And what you would do is to actually get a disposable out of this and dispose it. You might also use like a composite disposable and group multiple disposable in a single disposable and dispose them all the time, all together. And the way of doing this in the coroutine world is actually quite simple. Basically, every time we call launch, we get a job object. And on this job object, we can call cancel. And we can do all sorts of useful things on this job object. We can check whether it's active, whether it has been cancelled, if it's completed, if, for example, it threw an exception, if it has children, because yes, a job can also have children. And you can also merge multiple jobs using the join. This is quite advanced, so if you want to explore what you actually can do with jobs other than cancel, it's also quite interesting and quite powerful. Another thing is that if you're using architecture components in your Android app and ViewModels in particular, Coroutines works really well with ViewModels. And let's take a look at an example, for example. So we have on the left our ViewModel using our Retrofit API, and we are using RxJava to call our network endpoint. So we have a disposable. When we do API.getUsers, we are adding the return disposable to our composite disposable. Then we are clearing everything in the onCleared lifecycle method of the ViewModel itself. How you would do this in a ViewModel using coroutines is just call launch on the ViewModel Scope. This ViewModel Scope, it's actually an extension property of ViewModel, a Kotlin extension property. And what it does is it automatically cancels jobs based on the ViewModel lifecycle. So instead of remembering to add our job and to save it somewhere and to cancel it when the ViewModel goes through the uncleared state, we just call launch. So we just use our CoreTeamBuilders on this ViewModel Scope property of ViewModel, and it will be automatically cancelled when it needs to be. Another thing this ViewModel Scope does is actually sets the default dispatcher to dispatchers.main. So unless you specify your own custom dispatcher inside the launch CoreTeamBuilder, it will use dispatchers.main instead of dispatchers.default. And this means that everything inside it will run on the Android main UI thread, unless you specify otherwise. Probably something I should also mention is that this has been added in lifecycle 2.10 alpha 01, so it's actually not in the stable release yet. You need to add this dependency, which is the KTX dependency, which enables all sorts of Kotlin extensions for architecture components. And if you really don't want to wait for a stable release to use this ViewModel Scope, what you can do is actually have a look at the commit where actually Googlers implemented this ViewModel Scope, and you can just implement it yourself because it's really trivial. It's like 4 classes. It's just you can add it to, for example, your base ViewModel implementation without having to wait for them to release actually the stable version. Another cool thing is that the ViewModel Scope is also really testable because even though it relies on the dispatchers.main, so on the UI thread, and as you may know, the UI thread relies on the main looper of Android, and we can't use the main looper in unit tests. If you add this dependency to your project, which is the Kotlin X coroutine test dependency by JetBrains, we can actually override the main dispatcher for coroutines. So in this case, for example, we can create a thread executor, and we can then call dispatcher set main, which is enabled by the dependency at the top, and we can override the main dispatcher to a single thread. In this case, we can launch coroutines relying on dispatchers.main instead of our unit tests. And of course, at the end of our test, you can just reset the main if you want to keep it into a clean state. If you want to have further information on this, on testing with ViewModel Scope and testing coroutine in general, I suggest you go to these 2 links. The first one is actually an introduction to the ViewModel Scope. The second one is a code lab by Google on coroutines, which also includes a testing section. And yep, it's really cool. Another cool thing is parallel decomposition. So, for example, you have 2 network calls. You want to execute multiple network calls at the same time, and then just consume the result of both when they both result. But you actually want to execute the network requests at the same time to optimize your time. We don't want to wait for the first one to call the second one, of course. So this is how you would do it in RxJava. We can just call zip and then just consume the result of both. And in Kotlin, using coroutines, you might think that something like this is enough. We are calling get posts and get friends, and then we are consuming the result in this user profile object. And this is a suspendable function, of course. But actually, this is not enough, because what this would do is actually call api.getPosts, and once that completes, it will actually go to call getFriends. So we are not calling both endpoints at the same time. What we can do to make this work is actually wrap this into this async, which if you remember, is a CoreTeamBuilder. So you can wrap both for posts and friends into the async CoreTeamBuilder, and they will execute at the same time. And then we just add await when we are actually consuming the result of the async CoreTeamBuilder. The problem is that in its current form, this implementation has many issues. For example, if the coroutine that called user profile, so the main suspendable function, is cancelled for whatever reason, the posts and friends calls will not be cancelled. They will still keep going. And probably we don't want that. And the problem is that with this kind of implementation, if one of the posts or friends call fails for whatever reason, the other one will still keep going. And we will only get the exception once we go to the await call at the last line. So we're actually wasting time before getting the exception. A way to solve this is actually to wrap all our async calls inside something called courtingscope. And what courtingscope does is allows us to run both at the same time. So we will call both endpoints at the same time and then just return the result when we have both the results. And what courtingscope actually is something that defines a boundary, so a scope to our operation. All our coroutines become children of this scope. And if a parent job fails or is cancelled, so for example, if the coroutine that launched a user profile, suspendable function, is cancelled for whatever reason, it will also cancel all the children of the coroutine scope, so both the async scope. And of course, if a child fails, every other children will too, which is exactly what you would want from a production grade application. So debugging. So how many times have you seen the screenshot on the left here in this case? You want to debug an RxJava flow and you want to set a breakpoint. And actually the IDE is asking you, okay, so where should I set this breakpoint? Do you want it inside the Lambda? Do you want it outside? And then when your code stops inside the Lambda, you want to jump to the second one. It's always not that trivial. The main comparison is with coroutines, which everything is executed inside in a sequence, and it's actually pretty easy to follow. You just go to the next line, and everything works as expected. And if you want to have more information on this, there's also a really good talk by Fabio Collini on async code on coroutine, where he actually goes through these debugging advantages. Cool. So at this point, you might be wondering, okay, so we've been talking about coroutines for a while now. We've had a lot of comparisons between RxJava and coroutines, but I already have my project. I'm already using RxJava or whatever solution. What should I do? Should I just scrap all my RxJava code and switch to coroutines just because you say that it's good? Or should I just ignore you and keep using RxJava? So this is what I think about this. If you're already using RxJava and you actually don't feel any of the pain points that we discussed about, if you are fine with the RxJava chains and with the RxJava operators, then it's great. I mean, RxJava is great. You have a lot of useful operators. You have a lot of libraries to handle, for example, view inputs as streams, and it's great. So if you actually don't see why RxJava is not optimal for network calls, then you probably shouldn't consider coroutines. If your app architecture is based on reactive streams, so for example, if you're already using in your application some of the libraries I showed you at the beginning of the presentation, so if you are treating, for example, application permissions as flows, if you're treating sensors data as flows, you probably are fine. I mean, your entire application relies on ReactiveX streams, and having to deal with two different kind of asynchronous tasks, then probably it's not the best for you. The majority of your app code base is in Java. Well, coroutine doesn't work that great with Java, especially because the way coroutine work under the hood is that they are converted at compile time into something else. Every CoreTeamBuilder is compiled to different objects. So, of course, this doesn't really work well with Java. If your application is mainly written in Kotlin, or if you plan to use coroutines from Kotlin only, then it's great. But if you have the requirement of having to deal with a lot of Java code in your application, then probably you should think twice about using coroutines. these are the main 3 points which I would suggest you to keep using RxJava. For everything else, honestly, I don't see why not give Coroutine a try. It's really easy. It's really readable, and the learning curve is really not that steep as with RxJava. With RxJava, you have to understand all the operators or the primitive types. With coroutines, you're just dealing with functions, and you're using Kotlin's functional operators. For example, you can still use flat map. You can still use filter on collections, of course. You will probably miss some of the ReactiveX operators, like, for example, debounce, throttle. You can still implement those for coroutines, like high order functions, but you don't have that built in by default. Cool, so that's it for me. If you have any questions, I'm ready to get them. Thank you.